So welcome to another video. In this lesson, we're going to talk about the repetition structure, or what a lot of people call loops. We'll discuss how to implement a pretest loop using the do loop statement. We'll describe how to concatenate strings. We'll also identify and correct an infinite loop. An infinite loop is a loop that never ends, just keeps going, repeating the same sets of instructions over and over again for eternity. We'll describe how to implement a post-test loop using the do loop statement. We'll also explain how to use counters and accumulators and discuss how to implement a counter control loop using the for next statement. So repetition structures. These are referred simply as loops. Whenever you think of a loop, just think of something that repeats generally more than once. Not necessarily, they could repeat just, could just repeat once or whatever, but we think about it repeating several times in the general case. So here's just to get a little bit familiar with looping conditions. We specify when to continue, keep your foot on your car's brake when the traffic light is red. And so let's say every second you check to see if the traffic light is red. If it's still red, you keep your foot on the brake. If it turns green, then you know to let up off the brake, press the gas pedal. Another example is leave your windshield wipers on while it's raining. So you can think about every couple of seconds, you're looking at the windshield to see if it's still raining. If it stops raining, then you shut off your windshield wipers. So as you can see here off to the right here, we're keeping your foot on the car's brake until the traffic light turns green. So these are similar to each other. It's just a slightly different way of looking at the same problem. And so let's look at a pre-loop. In other words, with the pre-test loop, we're looking at our test at the beginning of the loop, not at the end. Notice here with the post-test, we're looking at the end to see if we should continue with another loop or not. With the pre-test loop, there's a possibility that the statement here isn't true. So we would just never do the loop at all. With the post-test loop, you're guaranteed to do the loop at least once. So here it says repeat while our number is less than or equal to 5. And so here we're going to display number and then add 1 to number. Well, if your number is already equal to 6 before you start the loop, now, of course, you look at step 1, it says to set it, initialize it to 1. So if we initialize it to 1, it'll loop through here, I believe 5 times. We'll display the value 1, and then we'll add 1 to num, so it makes it 2, and then we repeat through the loop again. But if we would initialize our value to 6 instead, repeat while num, which is equal to 6, is less than or equal to 5, that would be false. We wouldn't do the statement at all. So a pretest allows you to complete a loop 0 or more times. The post-test, because if you see here in the repeat and the second step here, we actually display num first, then we add 1 to it, then we check our statement. This will get executed at least 1 time, 1 or more times. So if you like flow charts, this is pretty much the same statements above using flow charts. I won't go into this since I did spend a little bit of time before on this, but we keep continuing through the loop until our condition here becomes false, and then we exit out. Same thing down here on this, on the second case there. The do loop, in Visual Basic, we have a do loop statement. So let's look at an example. If we're to pretty much do the last two examples in Visual Basic, here's the code to do that. We can use a do while, or what we call a do loop. Do while int is less than or equal to 5. We then display our number or value, and then we add 1 to it. And so this loop will execute up to 5, let's say 5 times, and we'll update label nums to, actually it appends the value onto the end. That's what the little ampersand sign here does, is it's a concatenation operator. In other words, we're adding on to the end of our code that we already have. In the second example here, we're specifying when to stop, do until num is greater than 5. So these two are equivalent. It just notice that there's a slight difference here. The difference is we have a do until, and up at the first example, do while. You could use either of these. If I had to choose one or the other, I would use the first example, do while. The reason for that is because other languages usually have a while statement. So if you get used to using the do while, it'll be easier if you've got to use other languages. Okay, let's move along. String concatenation, we did show that just a minute ago with the ampersand sign here. It allows us to be able to take two strings and be able to pin them together. Notice here, if city is equal to Atlanta and the state is equal to Georgia, GA, whenever you concatenate the values together, notice that there's no space between Atlanta and GA. If you want a space, you got to do what's shown here in the second case. And it adds a space there. If you want a comma, like what's shown in the third example, you would have to have double quotes, comma, space, double quotes in there. And if you want to add some extra text like she lives in, whatever, you can do that. You can go ahead and do that at the beginning, because Visual Basic doesn't care if it's a string or if it's text literal is what this is called at the beginning here. It doesn't matter. You just gotta it's just got to be a string somehow. It could be a hard-coded value like what we see here with she lives in, or it could be a value in a variable. Infinite loops, they're also called endless loops. And infinite means that it keeps going on and on forever. There's no stopping. And usually in programming, that's bad. Not always. There's times that you want to do that, but very seldom is that the case. The average loop isn't usually an infinite loop. You usually want to stop after you're done processing so many elements. And so if you want to create and then stop an infinite loop, I'll let you go through this test on your own, or that exercise on your own. I'm not going to talk about it. You just got to understand what it is, what an infinite loop is. And that usually it's something that we generally don't want to do most of the time. So let's look at a do loop, and let's look at the post-test loop. So here's an example to where we set num equal to 1. We then output the text like what we did before. A few examples ago, we add 1 to it, and then we check to see if num is still less than or equal to 5. If it is, we go up to the top of the loop again and continue executing it until we're done. You could do the same thing here with a loop until. And as you can see down here is the result of that, where it appends a value onto the end. So you start at 1, 2, 3, 4, 5, displays that data in that label. Counters and accumulators. We've already kind of seen these already. If you look at our loop here, we've got where we're adding 1 to num each time. That is a counter or accumulator. It means that you're adding something together. And so that's pretty much what that is. Down here, you can initialize an accumulator by just creating a variable, and then you can update the accumulator by having a variable equal to itself plus some other value, and that would update the accumulator. So whenever you think about an accumulator or a counter, just think about it as something that is adding values together. For next, actually, I like the for next statement. I try to use for next statements as much as possible. Part of the reason for that is because, go back here, notice here that we've got the int num plus equal 1. If you accidentally forget to put that in there, then you've created an infinite loop. That can cause problems. And if you're dealing with a set of values that you know, for example, in this example here, we're counting from 1 to 5. It's easier to write it like this in example 1. For int num as integer equals 1 to 5. And notice here we only have one statement. We don't have to have that accumulator, that counter in here. In the body, it automatically takes care of it for us. We don't have to worry about it. It's simpler code. It's easier code to read and understand, and it's one less thing you have to do, which means that it's less likely that you're going to make a mistake. Same thing with example 2 here. Instead of going from 1 to 5, we're going 5 to 1, and we put in this extra keyword here, step, and say -1, which means it will be going backwards. And so we'll be displaying numbers from 5 to 1. And you can also use the for loop, not just with integers, but you could use it with doubles, for example. So you have double rate equals 0.05 to 0.1 instead of 0.01. And this then would add the rates onto each other and displays 5, 6, 7, 8, 9, and 10% on separate lines. So most of the loops that we've seen before, we could replace those. Since we're doing just a simple basic counting, we could use a for next loop instead of those whiles. You would use a while loop whenever you're not sure the number of times you're going to be executing a loop. If you notice in these 3 examples here, we know exactly how many times we're going to be going through each of these loops, so we can use a for next. Comparing the for next and do loop statements. Kind of already did this, but we'll look at it again because it'll just be easier to understand. And if you understand it, that's great. If you don't, this just gives you a second chance here. For the for next, notice here, we have the int num as integer equals 1 to 5, and then just one single statement in the for next body, which where we're updating the nums label. Down in the do loop here, notice that we've got to declare int num. We don't have to do that up here in the for next statement. It will automatically do that for us. And then we got do while num is less than or equal to 5. You've got to do that comparison yourself. Then you update the num's text, and then you've got to which we have to do in either case. But then we also got to add 1 to the num variable. So if you look at this, there's 1, 2, 3, 4, 5 lines versus 3. This example isn't real complex, but if you start dealing with something that's much more complex, you definitely save a lot of time, energy, and have less chances of there being a bug or an error if you use for next. Flow charting for next. So here's the examples of doing the example 1 and example 2. Notice here that in the first example where we used the do while, we got to declare the variable, and notice then we got to do the check, and then if it's false, we display this and go back. If it's true, we stop. Over here, we notice it's much simpler. We check to see if int num is greater than 5. And technically, we don't have to do that. The for loop takes care of that for us because it knows we're counting 1 to 5. It does this internally, and we just got to display the int num. So that's about it. That's about it for this lecture. I'm glad you stuck through it. Loops are very important. It's something you're going to use a lot, so please take the time to go through and do the exercises, to do the assignments that you need to do, because this is a very important topic, something that you will use quite a bit. Thank you for watching this video, and I'll see you next time.